Well, thank you for the introduction, and thank you for inviting me here back to Briar. I was here, actually, I have a little bit of history of Briar. I interviewed for a position here back in 2004. It was a few years ago. The timing just wasn't quite right, but I enjoy coming back and seeing this wonderful campus again. So thank you for inviting me back. So I wanted to talk about the African Drone and Data Academy. This is a project that we started actually a couple of years ago through some experiments at my lab, and it grew to this educational program now, which is kind of a big deal with UNICEF, and they're putting a lot of investment now into the future technology capability of the workforce that we're targeting in the drone community. So we talk about drones, as being having a lot of different applications, and some of them we don't even anticipate that there's going to be a use for them. And this is a good example. I got the newspaper, a year ago, and I look at this article in the paper. It says, vaccines blocked as people died of cholera. So there's no application here for drones, but it's pretty obvious to me that there's a use case here that we didn't think about. So being able to defeat not only environmental conditions, but political situations as well. Drones have the capability of overcoming barriers that we have yet to anticipate. And so there's a lot of applications here that are going to be in the growth area for these aircraft and the technologies that follow behind them. And the Drone Academy is there to support that from the backside, to support the technology transfer to the innovators and the entrepreneurs that are going to carry this forward into the future. So UNICEF is interested in investing into drone technology, and they are looking at the supply of the donors. The donors are going to feed this new economy, including UNICEF Village Reach, which is involved in the last mile delivery of public health. Then there's the companies that deliver the products like Matternet and We Robotics and Rigitech. And then there's the service providers like UPS and BD Clinical Diagnostics. And so there's this whole chain of users and being fed by an interest and a real drive to see this technology come into the forefront of how it can help in the public health sector and other sectors as well. Okay, so other sectors, not just public health, but what about environmental security? So if we take a look at Malawi's got deforestation like other areas in sub-Saharan Africa and other places in the world. We can look at a 30-year period where we see a significant deforestation occurring. How do we take a look at this and manage it? How do we get a better view of these activities? And how do we address new agricultural technologies that are going to be adaptable to climate change and deforestation and other activities that we see encroaching on the developing world and other places. And then there's the applications that we see to support reforestation and reduction of deforestation in the Central American and South American areas, where this is a concept that we presented in Peru to monitor activities in protected areas where farmers have set up their activities. They're farming in non-sustainable ways, and so companies like Conservation International can come in and encourage shade tree growth of coffee, where the shade trees are helping to retain water in the watershed and prevent erosion. And so we monitor that with drones. We can keep track of what the farmers are doing, and then we can provide incentives for them if they actually comply with the conservation efforts. They are rewarded for it. They're given stipends, essentially, to continue their activities. So it's helpful in that regard to, even if you have illegal encroachment into protected areas, the farmers can actually see a return on this by helping the environment return to its natural state. Precision agriculture. So agriculture is a big beneficiary of drone activity, and so we're taking the imagery, we're looking at the near-infrared bands and other spectral bands to determine health of crops, And from this, we can then determine where stresses are most prevalent and how crops may be adapted to climate change. Innovative payloads, multispectral payloads, hyperspectral imagers are now coming down in price. They're becoming more affordable and accessible to smaller operations and lower cost solutions. Your problem is bugs. We've developed some technology at my lab to detect stink bugs. And so this is another idea that higher resolution cameras, lower in price, lower cost aircraft, we can now actually see bugs and count them on plants. And so the opportunities keep popping up. You keep seeing applications that I never thought about before, but now that you have the imager on the drone and the prices are becoming affordable to fly higher resolution sensors at a lower cost, all of a sudden it opens up these possibilities. Disaster response, another area that UNICEF is interested in. It's the same, you could look at this as also a public health application because displaced populations, disease transmission, it's all going to be perhaps made in a worse situation without proper management of a disaster environment. So there's products out there now to take aerial imagery and get a quick view of the situation. This is called Hangar 360. It allows you to get a 360-degree view of an environment that's been burned. This is a California fire, the Coffey Park area. There's these tools that Esri provides now where we can look at the before and after situations of areas. And so being able to, again, disaster management, being able to manage disasters, being able to assess problems, and then manage displaced populations. Very useful tools are coming out of this now. And then there's another tool by Survey, and this is kind of a neat program here where we can take a three-dimensional map, a map that's got areas that have been identified as areas of interest, and we can fly a drone virtually down a street and see it progressing down the map, and we know exactly where it is. So the imagery that we get off of the aircraft now is going to be fed back into a database where anybody can replay a particular intersection, a particular area that has been, it's an area of concern that we need to investigate. It's an easy way to display and quickly assess a problem. And then there's mapping and terrain classification. So there's more sophisticated uses of drones that we have looked at the Unmanned Systems Lab. So this is an application where we're looking at an aerial image that's already been converted into three-dimensional point cloud from the pictures that are being taken by the aircraft using stereo cameras. So we get obstacles that now can be used to plan a path for a ground robot or people that need to get into an area that's been changed. If there's any kind of a post-disaster environment and we don't have updated maps, we can use these aircraft now to get quick updated maps, three-dimensional maps, which allow us to then plan paths for either autonomous vehicles to go in and search for bodies or whatever we're looking for, and then also to plan paths for first responders to come in and handle the situation. Building information modeling is another interesting area to look at. So being able to take imagery that is in areas that are being rebuilt, reconstruction efforts. Question is, how does a donor know that their money is going to the right place? So these are images from schools in Nepal that were damaged from an earthquake. And what we'd like to do then is, my computer wants to update. Hold on. What we'd like to do is be able to go in and take aerial imagery and get a three-dimensional model of the structure as it's being built. And so the donors have confidence that the money's going to the right place. They're able to see productive use of their funds, and the building is being constructed to the built design. So these are all great applications, but the one that UNICEF is mainly interested in is public health. And I said public health covers a lot of areas. It covers not only drug delivery, clinical diagnostics, but also it can be related to disaster management, population repopulation, and recovery. So some of the areas that we've looked at, and some of the areas that UNICEF is very interested in, are things like using machine learning methods for cholera outbreaks and the prediction of where cholera is going to occur. We can use methods to evaluate a community and find the populations that are more susceptible to cholera growth and cholera spread, and this would be caused by sanitation points that aren't accessible to the community, or the income levels of the communities, or how far you have to go for fresh water, for clean water. So these are indicators that we may have a disease spread, and so we can use machine learning methods to quickly identify where these areas are, where the communities are more susceptible for cholera, and then we can be a little more proactive when the event occurs. Agent-based modeling is another method where we get high-resolution models using very complex models where we're modeling individual agents and how they behave, how people move around in a community, how they communicate with others, and how these become vector transmissions of disease. And so these are very, very complicated, require high-performance computing, but the end result is you get very detailed information on the possible spread of disease. And so this data can also be backed up by aerial imagery. And then we're working with a woman at University of Lancaster, Michelle Stanton, who's part of our Drone Academy work, and she's interested in malaria. So identifying environments that are more susceptible to the larva growth and what we can do to environments to reduce that so that the larvae of the Anopheles mosquito are not transmitting malaria. So we're flying into these areas in the littoral areas of waterways and bodies of water, finding areas that are going to be more susceptible to larva growth and then working to eliminate those. But I'm a mechanical engineer, and I love aerospace, I love airplanes, and so we started working on an idea of how do you build a low-cost aircraft? And can this low-cost aircraft be used to fill some of these gaps that the public health community is interested in? So let's take a look at an innovative aircraft design that's made out of poster board. Okay, so it's started as a poster, and it became an airplane. And it's got 3D printed parts in it, so the raw materials are really cheap. It's a poster, it's a piece of foam core like this, and then the 3D printed parts, a spool of plastic and a piece of foam core, and you have an airplane. So this design, which we call EcoSoar, got the attention of UNICEF. We took it to Malawi in 2017, and we flew this aircraft from a health clinic, the Gagoti Health Clinic. We flew it 19 kilometers beyond line of sight back to the airport. And we delivered a sample, a simulated set of dried blood spot samples. And the flight was remarkably successful. Everything worked, although the airplane that you see there flying is not the airplane we brought with us. It's the one that the Malawi University of Science and Technology students built. The one that we brought crashed. And so we had to fly the backup airplane, and the backup airplane did the job. It flew 19 kilometers, it delivered the simulated pack of dried blood spots, and here's a little story about how it all came together.
One other line. So you're lined up, okay, and this is right where it needs to be. Just roll, roll it, nice and gently, about the wing.
Have an extra left wing here, so on this airplane.
Lately, we've been looking at delivery of medical supplies to the local hospitals. I see that as one way of where drones will be beneficial, and also just inspiring imagination. I mean, the building of aviation in a place like Malawi, where a huge percentage of the people haven't even been close enough to an aircraft. Kids would get inspired to build drones and fly them, so would the youth. So I see more than one ways of drones being beneficial.
Right. So you kind of have to watch this as well.
That's exciting, hey?
It's very exciting. Finally seeing everything come into shape.
Ah, now it's even the propeller. Aren't you proud, guys?
Very proud. Can't wait to test it.
Bring it up to 40, Zach.
Airspeed is 11.6.
What is altitude?
Altitude is 20.
Altitude 20. Oh no. Back around.
Okay.
Wow, that wind, it's so scary.
Airspeed is 13.
Whoa! All right, man. Good job, Zach.
What am I going to fly as well?
Waypoint 6, very good.
Is it up there?
This is home, it's 3.4 kilometers.
That's really good.
I think we just lost
This is the airplane landing after a 19-kilometer flight. And again, this is an aircraft built by students from the Malawi University of Science and Technology after a 2-day workshop, having never seen the airplane before that. This is the flight path and the simulated pack of dried blood spot samples. So we went there thinking, okay, we've got this low-cost aircraft, there's not much to it, it's made out of poster board, that's cheap, it's made out of 3D printed parts, that's cheap. It's a $350 autonomous aircraft that's essentially disposable. It doesn't matter if it gets broken. I could drive over it, I can fix it for $5. It's not a big deal. UNICEF looked at that and said, yeah, that's nice, but we really don't want the delivery. We want you to teach an educational program with it. So that's how the Academy grew. And so that's why this really became a story about the African Drone and Data Academy to create a skilled workforce in Malawi and Africa. And so we started this class a couple of weeks ago. We're actually into week 6 now in Lilongwe. This is at the Diang University in Lilongwe, Malawi, and this is the class. We've got 26 students, and we are looking at new technologies to teach this class because they're post-baccalaureate students. They're science majors for the most part. They have technology backgrounds, but they're not necessarily engineers. So we need to do something about the engineering side of this to kickstart the engineering thought process. And so what we're doing, instead of a traditional classroom, where students would learn the theory first and then apply it, we talk about flipped classrooms, where students are going to be looking at the lecture online, but then they do the activities in class. We're looking at sort of an extreme flipped classroom where the students build the aircraft first, they look at how things go together, and then they talk about the theory later. So we can take this, and for somebody who's never been an engineer, like, what is all this stuff? What is it for? What does it do? Well, look what I can do with this. When this thing is open, I can say, you know what? It's not very stiff. It's a very flexible airframe, right? But as soon as I close it up and I glue it all together, it becomes rigid, and it doesn't twist. And so now you can start teaching things about closed cell structures. You can teach about the stiffness increase from a closed section. You can teach about area moments of inertia by just opening and closing this. You don't have to look at equations. What about the spar in the middle? How does that work to carry the loads? Well, I can basically see it. I glued it in there myself. I know exactly how that carries the loads now. And then we build in other technologies. So 3D printing technology is integrated in this. So you learn how to work a 3D printer. You learn about the design challenges and how to make things work and go together. So it becomes a tool, a great tool for teaching how engineering works and how it results in a functional product. And so we've developed a series of activities in this class where Module 1 is going to be drone technologies, then we get into regulations, and then we get into data products. But the laboratories are always first. The students are going to build the aircraft first. They're going to test them as they're building them. They're going to learn something about the mechanics and the aerodynamics about it. And then they're going to go through and configure the aircraft, and they're going to test them. And some of the activities are going to involve prop testing, where they're measuring thrust and performance before it ever goes on the aircraft. They're going to learn how to solder. They're going to learn how to repair equipment once it gets broken after a crash. And by the way, this is one of the mandates of this program is we have a majority women in the cohorts. So right now we have 15 women and 10 men from 8 different countries in Africa. And then we go into the classroom, we talk about the science. So now that they've already experienced what it takes to make a smooth surface, to make a low drag surface, they actually formed it and glued it all together themselves, and it actually flies at the end of the day. Then we go into the classroom, we talk about the theory of lift and drag. So why do we need a smooth structure? What causes drag? What causes lift? What's this camber for? What is that all about? Why do I have to balance the airplane? Why is the center of gravity important? What are the effects of altitude and density altitude or temperature on the aircraft? And then we talk about the regulations, and so students will have to learn about all the regulations that keep them safe to operate the aircraft. This all leads them to what's called a Top Level 2 certificate. And then we go out and flight train, and so the flight training is going to be focused on the activities around a simple quadcopter where, again, they built the aircraft, they tested it, they did all the performance analysis on it before they flew to make sure the center of gravity and the weight is correct. And then at the end, they're going to get this certificate. So this is an internationally recognized certificate the students will get that really puts this as a Category 1 program because there's only a few of these Top Level 2 programs in the world, and this one is one of the few that's a 10-week program that covers all these other areas of technology. So then we finish up this class with a data analytics portion, and the data analytics portion is going to include things like what we talked about before, using machine learning methods to identify community activity, how people are moving around, how they move from sanitation points to borehole well points, and how that could influence outbreaks of things like cholera. And so these are public health considerations that we're very interested in. So the aerial imagery becomes just another tool to find a new method of exploring the predictive analytics that we get out of machine learning technologies, out of computer vision methods to resolve data into manageable products that are going to be easy to analyze and connect the dots with. So this is where we are today. We've got this quadcopter that the students build, they assemble it themselves, they test it, they debug it. We've got a flight team on the ground training the students. We've got 26 students enrolled in this class, and we've got 3 of them who we've pretty much identified as being the instructors for the next cohort. And so they'll be instructors in training for the next 10 weeks, and then hopefully after that they'll be teaching this class themselves, and we won't have the Virginia Tech students in there to support. And what you see down there in the lower right is the EcoSoar that we just saw. And so this is going to be one of the flights of the 6 aircraft that we just built a couple of weeks ago. It turns out that out of the 6, 5 of them flew the first time, and 1 of them had a little bit of an accident, but then it flew again after that. So all 6 aircraft were able to fly. So this has been a real learning experience for us too. I mean, it's not the easiest environment to teach in, and so we're learning things as we go along, but we're getting to the point now where we're kind of sitting back and saying, okay, the worst of this is over. We kind of know how to run a drone academy, and we know what it takes to empower these students to have credentials that are going to give them good paying jobs and be contributors in the drone environment. But it's also going to fulfill UNICEF's goal of having a public health reach with drones. They're going to help us deliver to the last mile. It's either going to be clinical diagnostics or getting the data that we need to help populations that have been displaced. And so, as I said, we have the UNICEF, we have the donors, we have the universities, Virginia Tech, the Malawi University of Science and Technology, and we've got this 10-week program now that's going to turn into a master's program down the road. So in a couple of years, we'll be offering a master's degree out of this. And this will include a 6 to 12-month internship, so students will be able to take the technology they learn in the class and then apply it to a job that they have gotten to get experience, and hopefully that'll turn into a permanent career. And throughout this whole program, we're training up in-country instructors. So eventually, Virginia Tech's going to walk away from this, and it's going to be the African Drone and Data Academy that is in Lilongwe and growing Pan-Africa to other countries with other partner universities. So the big goal of this is to have an ecosystem, a drone ecosystem, where you have things like the drone port concept that Foster and Partners has proposed from the World Bank. And the drone port concept says that we're going to have a center of excellence. We're going to have students that come out of a program, they're going to be trained, they know how to operate drones, they know how to analyze data products. But then we have the supply side. We have the farmers, and we have the UNICEFs of the world who come in and say, we need services. We need services. We're not the experts of this. We want to bring in your trained technicians into this program to help us. And so these become centers of excellence where the students then become service providers to the parties that are interested in the data products. And that's how the economy grows. That's how we want to grow this. That's the vision. So that's the vision. But the big question is it really ever going to happen? Okay? I'm a realist, and I know that this looks good, and we're teaching valuable skills to these students. Yeah, that's true. That can't be argued about. But is there a business case for the ADDA, and do we need a business case to make this survive? What's going to happen to the investment? Is it going to go anywhere? You know, what job opportunities can we expect these students to have? Will the students be able to start their own careers? Will they be able to be innovative enough and have enough of an entrepreneurship spirit to start their own companies? Is it sustainable? Don't know. And on top of all this, development work is messy. It's really, really difficult to work in this environment. We've had one student who got malaria. We had another student whose brother died in a car crash. We had many students get sick. My instructors have all gotten sick. The power is unreliable. There's a lot of challenges in this environment. But the question is it worth it? So Regiza, on the left, is one of our students. Regiza is a resident of Zaleka refugee camp, which is about a 40-minute drive north of where we are. The refugee camp is a difficult place to visit. When I was there in July, there were 28,000 residents, but their population is increasing about 500 people every month, and only 3% ever get out. So the statistics aren't good. Regiza came in through the Democratic Republic of the Congo, And he's the only one of his family that's there, so I'm not exactly sure what the full story is. But this is where he lives. It's a small concrete apartment that he's got at the refugee camp. And he's been there for 3 years, and he's actually picked up English very well, coming from a French-speaking country. And he's running some of the computer labs at the refugee camp. And so we got to know Regiza, and we said, you know, we're teaching this drone course. Maybe you should apply for it. So he applied for it, and he got in. And he's one of our better students and may become one of our instructors next year. So clearly, I would say there's value in this, maybe not necessarily from the first point of saying, well, is there a business case? Is this actually going to make money? Do the dots get connected from what we're putting into this? But when I look at Regiza and I say, you know, I could put him in my lab at Virginia Tech and he'd just hit the ground running, I just kind of feel like there's value in this in the sense that we need to share our ideas and our technologies and spread them as far as we can and see how they grow. And so there's a new economy, there's a new business that we see in sub-Saharan Africa where you kind of leapfrog. It's one of these leapfrog technologies that we go past all the infrastructure development that's not there, we go past centralized systems that aren't there, and we leapfrog into new technologies, decentralized systems, remote deliveries using drones, data products that make us smarter and make us make better decisions faster. All these are growing fast in an area that needs it, but we need it too. And so I really see this as an investment in everyone's future because it's an experimental, it's a fertile experimental ground to try new technologies that we're going to see growing as the future comes forward to us. So with that, Zikomo, thank you very much, and I'll take any questions if there's any. Yes?
To a clinic 30 kilometers away.
Yeah, so EcoSoar, the question is, how long is it going to be before we can make a 30-kilometer delivery? So this airplane will go 25 kilometers, believe it or not. There are commercial operations now that'll go 80 kilometers, and they are well-designed aircraft. They're very expensive aircraft. They're anywhere from $20,000 to $70,000 each. There's a variant of this aircraft that we're working on in my lab that'll go about 60 kilometers and carry a unit of blood. So a unit of blood, 60 kilometers, in my mind, is a threshold for the cost benefit. If you're looking at what it costs to deliver something on a motorcycle or a person carrying diagnostics or a vehicle over unimproved roads versus this, which has a sterile delivery chain from takeoff to landing, that's where the break-even is. So I think an EcoSoar, say at $500 a copy, that can go 60 kilometers with a unit of blood, now you're starting to talk about something that makes sense. Yes?
Is that something that's realizable in the next 5 years?
Absolutely. It is. Now, I think we need to explore how this is going to grow as companies come along and they have new aircraft designs and they've got new business models on how this works. The business model that I think works great is having a low-cost aircraft that's operated by a sole proprietor that's going to be in a decentralized world that they can provide services locally where the services are needed on an on-demand basis. Yes.
So, if you can, please speak a little more about the relationship with UNICEF, how that works.
Yeah, so UNICEF is kind of a new world for a mechanical engineering professor. And it came about because they set up a drone corridor, what they call a corridor. It's a circular area in Malawi to test aircraft. And so they've got permission from the Department of Civil Aviation to run these experiments with limited regulation. And so it's an 80-kilometer diameter area in Malawi around Kasungu. And this has allowed companies to come in and test their technologies with limited regulatory interference. We were one of them. We came in and tested EcoSOAR in this drone corridor. Because UNICEF set this up, they sort of put the environment in place to grow some of these ideas and look at the technologies and the possibilities. Yes.
I have 3 questions for you. The first one is, what is the payload for this craft? So if you're talking about delivering medicine from one place to another, how much actual medicine are you going to be able to move from one place to another? Because to me, that seems like a very small craft to deliver a beneficial amount of medicine from one place to another.
Yeah, it's a good question. So it's 130 grams in this. The extended version of EcoSOAR with the bigger wings is just a wing extension that we put on it. That'll carry 600 grams, which is a liter of blood. So it's not much, but a liter of blood is actually, now you're starting to talk about something that's worth delivering. The dried blood spot samples that we carried doing clinical diagnostics can be a pretty lightweight payload. And once you know what the patient needs, then the appropriate medications are ordered and delivered.
Okay, so the second question I have is, it seems to be made out of paper. How does that upstand with a time period with different types of weather patterns? Say, for instance, rain, wind.
Yeah, so 2 things. It holds up pretty, we don't want to fly in rain. We can't fly in rain. Most of these aircraft can fly in a little bit of rain and it's not going to be a problem. There are ways to treat the outside of these airplanes are actually covered with packing tape, and so they're semi-waterproof. But the other point of this is that, again, this aircraft is very cheap and it's somewhat disposable. And as UNICEF discovered along the way, maybe this isn't the world's best airplane for delivery, but it's a really good airplane to teach technology. So it becomes, you can have the vision of where this is going by building it and understanding what it's there for to do deliveries autonomously. But really, it's more functional in the classroom.
And my third question is, so this program, was it originally designed as a way to kind of introduce an environmentally friendly aircraft for Africa, or is it more originally designed to educate people on how they could improve poverty situations into a beneficial one?
Yeah, so let's say the environmental sustainability part of this, one thing that UPS is interested in, and all the delivery companies, Wing, Project Wing, the companies that are doing deliveries in the US are looking at carbon footprint. And clearly you can make an argument for that. If you're delivering small packages and you have to go repeatedly a 5-minute trip in an urban area, your carbon footprint is going to be smaller. Another thing about this aircraft is one of the things I want to do, and I haven't been able to do it, is make it out of cornstarch. So it's foam core now, but cornstarch is like foam, and if you get paper on it, you could have a totally water-soluble aircraft. So that's on our radar. The other thing is we just put together an airplane made out of recycled water bottles. So I'm not going to say this is the world's most practical solution for recycling plastic, but we have a technology. We have a professor at Virginia Tech, Chris Williams, who has put together an extruder to take water bottles, chip them up, extrude the plastic, and 3D print parts. And we're going to fly that airplane next week. And one of the companies that's involved in the deliveries that UNICEF is hosting in Malawi is Swoop Aero. They're in Australia. And when I told them about this, they got all excited because their whole airplane is 3D printed. So they really could have pretty much a recycled airplane coming off the line.
Okay, so you talked a little bit about the extreme flipped classroom. What were some takeaways that you saw from using that model, and how is it translatable? How would it be translatable to universities here or high schools, et cetera?
So that's an awesome question, and I don't have the answer yet because we're halfway through the course. So I am going to start, we're going to start asking the question formally, informally to the students, but we're actually applying for a more formal process in IRB to go through the second cohort and evaluate this. The second cohort starts up in April. My initial feedback from the students is they like it. They like doing the labs first, and they like coming into the lecture second. The only thing we changed is to put the lecture the next morning, because if the lecture is later in the day, they're falling asleep on me, so that never changes. So we're going to do the lab the first day, the second day they get the lecture in the morning. But so far, the response has been great. They like it.
You had mentioned about an application process that the students apply for this program. Is there a specific quality in the students that you're looking for in the application process?
So we are looking for students that have a science or technology background. And that has been pretty much the case with the entire cohort that we have now, the 26 students. We have a lot of GIS background, a lot of geospatial information systems background, data analytics. A lot of them work for like the water authority or natural resources or fisheries, and they are looking at applications of how they can collect the data that they analyze. So it does seem to be a kind of a theme that I do see the practitioners of analyzing data are now coming forward saying, we want to collect the data ourselves and be mobile and flexible and autonomous to go out and collect our own data instead of relying on somebody else. So this again goes back to this whole entrepreneurship model that companies could grow out of this, where they have their own particular data products they can analyze and provide the data products to a customer. Not only fly the aircraft and collect the data, but then analyze it also. Okay, well, that looks like about it. So thank you very much. I appreciate the invite to be here. Thank you.